Hey guys, and welcome to this video on truth tables. So here we have a truth table, and down in the bottom left we have a note, and this note is the implication identity that states that P implies Q is logically equivalent to not P or Q, and we're going to use that later on in this video, so that's why we have that down there. All right, so let's go ahead and get started. We want to complete the following truth table here. And so let's start off by assigning true and false values to our P, Q, and R variables. All right. And we're going to see all the different combinations of true and false we can make with these. And then we're going to look at the rest of the columns to see their true and false values. All right. Okay, so I'm going to start off with assign false to P, and I'm going to use F for false, and I'm going to use T for true. Okay, then we're going to give Q, we'll assign false to Q as well, and false to R. So that's one way that these three variables can be assigned the value true or false. And there's going to be 2 to the power of 3 ways that this can happen, which is 8 ways. So there's going to be 8 rows here in the truth table. Okay, so next we'll say P will be false, Q can be false as well, and then R can be true. All right, next we'll do P is false, Q is true, and R is false. Then we'll do P is false, Q is true, and R is true. Then we'll do P is true, Q is false, and R is false. Then we'll do P is true, Q is false, and R is true. And then we'll do P is true, Q is true, and R is false. And last but not least, we get true for all 3. Okay, now let's look at the next column. We have P or not Q. So that means wherever we see that P is true, then this whole statement is going to be true regardless of what not Q is. So let's just look wherever P is true, and P is true in these last 4 rows. So we know the statement is going to be true there. Now, if we look at not Q, that means we want not Q to be equal to true. So then it doesn't matter what P is. So for not Q to be true, Q needs to be false, because not false is true. So let's look wherever Q is false, then we put true in that row. Okay. And then everywhere else, this expression P or not Q is false. So we're going to put false or F in the rest of the rows. All right. So now, next we have not R implies not Q. And that's where our note comes in handy down below in the bottom left. So let's go ahead and write that out. We have not R implies not Q. And let's see what that is equal to. Well, that's equal to not R or not Q. And actually, I don't know why I wrote that line there, because we have to kind of see what not R is. All right, not R is just R. And so this is logically equivalent to R or not Q. Okay, so that means that anywhere we see that R is true, this whole statement here will be true as well. Okay, so R is true here, 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 and here. So those are the 4 rows that R is true. Okay, next we need to look at not Q. And similar to the last column that we looked at, our Q needs to be false in order for not Q to be true, which is what we want. So let's look to see where Q is false again, and then we're going to put true wherever Q is false. So that is in this row here, and Q is false in this row here, and okay, looks to be it. Okay, so now everywhere else, or the other 2 rows, we just put false. Okay, now we have this last statement. P or not Q implies not R, implies not Q. So it looks difficult, but again, we're going to use this note down here to help us figure out what this really means, or what this is saying. So now I'm going to put this little bar here, this separator, and we're going to rewrite that statement. P or not Q implies not R, implies not Q. So what is this logically equivalent to? I'm going to go down below here and use that implication identity. So that means that this is logically equivalent to P or not Q let's see. Oh, let me go back here. Let me erase that. Okay. So this is logically equivalent to not P or not Q, or not R implies not Q. Okay. So this looks like the previous 2 columns. Here we have this column up top, okay, and here, this expression, we have this column here to look at. So we already have their true and false values, so this is great. So now this means wherever this column is true, our statement will be true. So let's look to see every place that that's true in that column. All right, so we're going to be looking in the first row. We see true, true in the second row, true in the 4th row, true in the 5th, true in the 6th. Oh, did I? Yeah, 6. And true in the 8th row. Okay. All right, so now let's look at the other side of this OR operation here. And wherever this is false, not false will be equal to true, right? So we want this to be false. So we want to look to see wherever this is false, our statement will be true. Okay. All right. So let's see. We only have to look at rows 3 and row 7. So it's false in row 3. So that means that our statement will be true. And it is true in row 7. All right. So here our statement will just be false. All right. And that's basically it. I hope you guys enjoyed this video. Please leave any questions you have in the comment section below. Don't forget to hit that subscribe button to subscribe to this channel for more videos on discrete math and computer science topics. And if you enjoyed this video, please share it. Maybe others will enjoy it as well. And thank you guys for watching, and I'll see you all In the next video,